Good morning, students. Here we are going to start the lab session. Like we are going to prepare 8 lab videos. So daily one video will be uploaded in which one experiment is going to be covered. So you people watch the videos and write those things in one separate book. Those who have not got journals, we will provide that facility to provide you the journal. Okay. So let us start with our labs. See, this year in 2020-21 academic year, we have only 8 experiments to be performed, and those 8 experiments which we are going to do, they are resistance per unit length of the wire, resistivity of the material of the wire, comparison of EMF of 2 cells, internal resistance of a cell, figure of merit of galvanometer, conversion of galvanometer into voltmeter, focal length of convex lens, and semiconductor diode. So these are the 8 experiments which we are going to perform in this year. Okay. And the scheme of evaluation remains same, that is performing the experiment 20 marks, Viva OC 4 marks, practical record 6 marks, total we have 30 marks. So only these 8 experiments you are supposed to do. Okay. So here we are going to prepare the videos. Suppose once physical classes starts, you will get a chance to do this physically in a lab. Okay. So let us know this. Okay, hello students. Now let us start with the first experiment, that is resistance per unit length of the wire. So let us see how this experiment works. Here, say for our second PU experiments, like about the journal ratings and all, how you have followed in the first PU, in the same way you need to follow, in your journal, like the unruled part, the white part, first you need to write here circuit diagram, then draw the nature of graph, then write the tabular column. After that, in the next unruled page, do the calculations in how you have done in the first PU. In the same way you need to proceed. And in the ruled part, here you need to write first aim of the experiment. Before that, first experiment number, date and title of the experiment. Then you proceed with aim, then write apparatus, principle, formula, procedure. Okay, calculations you have to do on the white sheet only, in the unruled paper itself. Okay, at the end of the experiment, you need to write the result on the ruled paper only. At the end of the experiment, write below result with the following result sentence with the proper SI unit. Okay, this is how you need to follow. Okay, in the white page, first write circuit diagram or any apparatus diagram if you have, then draw the nature of graph, then tabular column with the entry of the calculations, then write the proper calculations below the tabular column, and on the rule size, experiment number, date, title of the experiment, aim, apparatus, principle, formula, then write procedure. At the end you write the result, okay, with the proper SI unit. In this way you need to proceed with the journal writings. Okay. Now let us start with the first experiment. Dear students, in the second PU experiments, these are all very easy compared to the first PU experiments. In the second PU experiments, majority of the experiments are electrical experiments, 1 or 2 are what, optical experiments. Okay. In this way we are classifying electrical experiments and optical experiments. So in this lab we are going to do those things also, means electrical experiments as well as optical experiments. So here we are going to start the first experiment, that is resistance per unit length of the wire. See, we have seen this already, like in the current electricity chapter. What do you mean by Ohms law? So everyone, we know that by maintaining constant temperature and other physical condition constant, the current flowing in a wire is directly proportional to the potential difference across the ends of a conductor. Suppose if I chosen any conductor in which current is flowing, that if I am maintaining surrounding temperature and other physical conditions of that wire constant, so the current flowing in a wire is directly proportional to the potential difference across the ends of the conductor. So this is what Ohms law. Ohms law will work only if you are maintaining temperature and other physical condition of that substance constant, of that conductor constant. Okay. So here let us start this. first, as I said you, first you write the aim. What is the aim of this experiment? Determination of resistance per unit length of the given wire by plotting a graph of current versus potential difference. So, here you have to do an experiment and you need to calculate or you need to write the values of current in one column and voltage in other column, and you need to draw the plot for that. So, this is what your aim of the experiment. Then what all things required? What all the apparatus required to do this experiment? We need a unknown resistance wire, means a wire will be given to you whose resistance we do not know. From the Ohm's law setup, we are going to calculate it. Okay. So, we are provided with the unknown resistance wire, then you need to get battery, then take voltmeter to measure the potential difference, and battery to give the energy to the circuit, and voltmeter to measure the potential difference, ammeter to calculate the amount of electric current, then plug key. Plug key is like analog switch, means on and off, okay, to protect the circuit. Then we need actually meter scale to draw the slope and all in the graph sheet. Then we require rheostat. Okay, rheostat is what? An example of variable resistor, means by varying the resistance of the circuit, we are going to calculate the current and potential difference. Okay, and we are going to draw the graph. Okay, so this is what about apparatus. Now look at here how the experiment works, means this resistance per unit length of the wire, it is based on what principle? So here then like how we are going to calculate the resistance per unit length of the wire, it is on the basis of what? Ohm's law. So, what Ohm's law says? Ohm's law says the electric current flowing through a conductor is directly proportional to the potential difference across the ends of the conductor when the temperature and other physical conditions remains constant. That is, potential difference is directly proportional to the current. So, by removing this symbol, proportionality symbol, we need to put a constant, that is the resistance of the given wire. So, V is equal to IR. This is what your Ohm's law. Then what formula we have to involved in this experiment? We are going to calculate the two things, means Ohm's law here we are going to see with the help of graph sheet. Okay. What is that? So, first we are going to calculate resistance of the wire, that is R equal to 1 by M, where M is the slope of the graph. Like once you plot current values in one column and voltage in one column, draw the graph and take the slope. Since it is a ohmic, means conductor is what? Ohmic device. So, you are going to get a linear line. Once you get a linear line passing from the origin, then you need to draw the slope. How we are finding the slope? We know already in mathematics, but like M is equal to y2 minus y1 divided by x2 minus x1. Okay, in that way you need to calculate slope. So, here why it is 1 by M, the value of 1 by M gives the value of resistance, because we are plotting current versus voltage. On y we have current values, on x axis we have voltage values. So, the resistance is 1 by slope. Else if it is V versus I, we could have taken directly resistance is nothing but slope. But here I versus V plot you are doing in a graph sheet. So, 1 by M will give the value of resistance, that is 1 by M means 1 divided by I by V, that is equal to V by I, hence V equal to IR. So, this is how the things goes on. So, 1 by slope will give the resistance per unit length of the wire, where R is the resistance of the wire, M is the slope of the graph. Then you calculate resistance per unit length of the given wire. So, this unit length, the length of the wire will be given in the given data in the question paper they will give, or in the lab. Initially we will tell you this, that this is the unit length of the wire. For that unit length you need to calculate the resistance. This resistance of the wire, it is unknown. From the Ohm's law setup we are going to find out the resistance of the given wire. Okay. So, once we get the resistance by taking a reciprocal of slope, then we need to divide simply by unit length, that is R by L, where L is what? Length of the wire. Okay, students. So, here this is the name of the experiment, aim, apparatus, principle, then formula to be used. Now, let us go with the procedure. Okay, students, see here, let us know about the procedure. See, procedures I have written, you can say this, I am telling you simple way. See, procedure is very simple, like you will be provided with some unknown wire. See, this is what your unknown wire. Okay, this is the given unknown wire which I have winded on it wooden stick. So, this unknown wire whose resistance you are going to find it out by drawing the by drawing the graph of current versus voltage and taking the slope of it. Okay. So, look here now. So, the procedure will be very simple. Just to see the circuit diagram, see these things you have to draw on the white sheet, okay, on the left side. In the circuit diagram, first procedure you have to write the connections are made as shown in the figure. See, in all the experiment, the first point should be the connections are made as shown in the circuit diagram. Okay, so then see, with this procedure, first you need to understand how this circuit diagram works. See, this is your circuit diagram of the given setup. This is a battery. This is a plug key. This RH means rheostat, a variable resistor. Here there is no connection. Okay, here there is a gap. So A means ammeter, V means voltmeter. This resistance is R, means the given wire whose resistance is unknown, means like you will be provided with this kind of unknown resistance wire, you need to connect here. Okay, so this wire has some resistance. That resistance you are going to find it out by plotting current versus voltage and taking the slope, reciprocal of slope will give the resistance of this given wire. Okay, so the circuit connections are made as shown in the figure. So here we have a battery. The bigger line indicates plus sign, which is connected to ammeter, and the negative sign is connected to the plug key. Why we need a plug key? To protect the circuit diagram. See, in all the experiments, whenever you are doing, make sure that without battery on, always your switch should be, means it should be opened. You need not make the circuit close unless and until you switch on the battery. Okay, first do the connections, remove the plug key one side, let the circuit to be opened initially. Once if everything is correct, then switch on the battery, then you plug in. Okay, then you plug in the circuit. Okay, so this is what rheostat. Experiment is very simple. Rheostat, at one position of the rheostat we have to fix. Once we fix some position in the rheostat, we will be getting some current in the ammeter. Okay, so once we set the current, we need to see what voltage we are getting. Okay, so simply it is by varying the rheostat, you need to see current values and voltage values, that's it. And once you get some 5 readings of current, corresponding voltages value will be also coming, and you need to draw the graph. Okay, so it's very simple experiment. I will show you with the demo. Okay, so here what theoretical point you need to understand here is, always whenever you get any black box, any kind of a device, if I want to measure its current, that any black box or any kind of device, if you want how much current is flowing in that device, how you will connect ammeter to that device? Of course, in a series. Suppose this is my unknown wire. I want to know if complete circuit is done. I want to know how much current is flowing in the wire. I need to connect this wire in series with the ammeter. So whenever we are finding electric current, we need to connect ammeter in series with the given device. If I want to measure what is the potential difference across its ends, so connect voltmeter in parallel, but ammeter in series. Okay, suppose say, see, this is your ammeter. I have taken milliammeter. If I want to know how much amount of current is flowing here, I need to current in this way, series. Okay, because here one wire will be connected, one wire will be connected to some other part. This is what the series connection. If I want to measure its potential difference, see, this is what your voltmeter. If I want to measure its potential difference, I need to connect it parallelly, means both the ends to be connected like this. Okay, both the ends to be connected like this. Nothing, just open the screw, wind the wire, then tighten it. This is how you have to do all the connections. Understood now? So you should not forget, ammeter is connected always in series to calculate the electric current, and voltmeter is connected parallel to measure the potential difference across the ends of the given object. Okay, so hopefully you have understood this. So procedure is, connections are made as shown in the figure. Rheostat is adjusted for a particular value of current I and current I. Corresponding voltages V are noted down. Experiment is repeated for different values of current I by setting the rheostat, and corresponding voltages are noted down. Then draw the graph of current versus voltage and take the slope M. Reciprocal of the slope gives resistance R of the wire, then calculate R by L. Look at here. So here I versus V. Here A, B, I have taken 2 points on the y axis and 2 points on the x axis. So slope M is what? Slope M is AB by y2 minus y1 divided by what? X2 minus X1. So that is, what are the Y values? AB. So AB divided by what are the X values? CB. So resistance is what? 1 by M. So that will be CB divided by AB. Okay. So in this way you need to calculate the resistance of the given unknown wire with the help of graph. Then observations. So the given unknown wire means the length of this wire will be given to you, that is, in our experiments we have given you 1 meter wire. Okay. So experiment is simple. By setting rheostat you are going to get current value here, and this is your unknown resistance R whose voltage you are measuring. Okay. Set the current value, note the voltage, plot the graph. Okay. Let us do this now. On the white sheet you need to draw first circuit diagram, then draw the nature of graph, write observation, then below the tabular column. In the next page do the calculations. At the last where you have written procedure, no, below procedure write the result of the experiment. Now let us start the working. Okay, look here students, these are your apparatus. Here we have connecting wires, these are must for all the experiments. This is a single strand wire, here we have a single strand. So these are called what? Single strand wires. We are using it as connecting wires. See, this is your plug key. This is like analog switch we can say. Here it is complete metal part. Once you press this, this complete will be one single metal. Okay. So how to make the connections? Like this screws you have to lose it, and you need to wind the wires, and this is how you are going to use in a circuit. Like if I remove this, circuit will be opened. If I close this, circuit will be closed. Okay. And these two screws should be tightened, okay, when you are connecting the circuit diagram. So this is one way switch or one way plug key. This is your KB supply from which you are going to get the electricity supply. Here this is your battery, okay, the battery eliminator. Here look at here, this is black color which indicates negative terminal of the battery, red color which indicates positive terminal of the battery, and here different voltage ratings means voltage values, supplies value they have given 2 volt, 4 volt like this. If I want 2 volt, keep this knob at 2 volt. If I want 4 volt, keep at 4 volt. In this way you need to vary by different voltage readings, okay, but most of our experiments will work on 2 volts or 4 volts, that's enough. So let us keep it at 2 volts, okay. So this is on and off switch. Fine. Here also the connections will be same, just lose the screws and tighten the wire, then fix it, okay. This is your battery. Then we have here ammeter. Here I have chosen milliammeter, means here in our circuit diagram the current is very small, so I am using what? A very low range ammeter, that is what? Milliammeter. You might have seen here MA, M indicates milliampere. So 0 to 500 milliampere range of this milliammeter. So whenever you are using milliammeter in a circuit, make sure that you are using in series, okay. So ammeter should be always connected in series, okay. This is your ammeter to calculate the electric current I. Then we have voltmeter. See, this is your voltmeter, positive side, negative side. Here the range is from 0 to 3 volt. So voltmeter is connected in parallel to the given device in order to measure the potential difference across the ends. Then we have a rheostat. See, this rheostat has got 3 terminals, one terminal, second and third terminal. Okay, in the circuit diagram we have left one part, so any one part you can leave and remaining 2 parts you can use, means any one among the 3 terminals you can leave one terminal and use the 2 other terminals. Okay, here also you need to simply lose it, wind the wire and tight it, okay. And here the windings of the wire are there on this part. So different positions here will give the different value of resistance. So rheostat is an example of variable resistor. Different pointings at the rheostat mean each wire winding depending on the length, each windings of this rheostat will give the different resistance, okay. If you vary this, your resistance is going to vary. So hence it is a rheostat, which is the example of variable resistor. Last, say this wooden stick just I have taken for our experiment sake. The main thing is this wire. Okay, this is any immaterial wire. Okay, maybe it is copper wire or aluminum wire in which current flows. That kind of wire we are taking, whose length you will be provided initially. So here the complete length will be of 1 meter. We have wind it out on this wooden stick, and we are going to use this as unknown resistance wire in our experiment. Okay, so these are all your experiment setup, and take graph sheet as well. Graph sheets, take the graph sheets and put your keep your pencil, rubber, those things, everything ready, because in order to draw a graph we need those things. And okay, let us start the working with the circuit connections. Okay students, look at this. This is what our circuit diagram. We have ammeter, battery, plug key, rheostat, unknown resistance wire and voltmeter. So let us connect according with this. See, take a battery. Okay, so just switch it on, don't just plug in, don't switch it on. Okay, make it off until we complete the circuit. Let it be off. Now take two wires. First, see, ammeter we have, then take voltmeter, then we have unknown resistance wire, and we have what, rheostat. Okay, so according to the circuit diagram I have kept everything. We have battery, plug key, rheostat, ammeter, voltmeter, and this R means unknown resistance wire. See how connections we need to do. First, take the battery positive connection to the plus of the ammeter. So battery positive connection, see, you need to wind this wire, or here there is a hole, you need to fix it here. Just tight this and connect to the positive of the ammeter, and connect it to the positive of the ammeter. Okay, just connect here to the positive of the ammeter. Okay, then negative of the ammeter is connected to the parallel combination of resistance and voltmeter. So here I am taking one more wire and take a connection from this milliammeter. Okay, now do the, just first connect this parallel and connect this wire here. So this we are going to do now. R and V are parallel. With that there is a one wire from the milliammeter. You tighten this, you just tight this and connect it here. Okay, so one side connection is finished. Now this side, so negative and R, negative side and R are connected. With the help of this, it is connected to the rheostat upper terminal. Now again connect these two wires. Just tight this. Okay, now this is what your rheostat. I am using the upper terminal. I am just, it has, I said 3 terminals now, 1, 2 and 3. So I am leaving this terminal. Upper terminal means this one, arrow marker. So use this arrow mark terminal. Okay, so this arrow mark indicates this connection now. Leave this connection as it is. This connection, okay, the other side connection, give it to the plug key. Okay, so this connection, just lose this, tight the wire, fix it. Okay, then this should be off initially. Just tight over here. Then take one more wire and connect it to the negative supply. This is your plug key. It should be off until you switch on the circuit and make sure that the circuit is correct. Then only switch it on. Then connect it to the, from the plug key to the negative of the battery supply. Okay, now connections are completed. Just see once again, we have taken battery, from the positive of the battery connected to the red end, means positive side of the milliammeter, from the negative of the milliammeter it is connected to the parallel connection of resistance R and voltmeter, this wire, and these two side negative of voltmeter and unknown resistance wire. This wire has been connected to the upper terminal of the rheostat. This terminal has been left it out, and the other terminal it is connected to the one side of plug key. The other side of plug key is connected to the negative of the battery supply. Okay, so this completes the circuit diagram. Don't switch it on, first you check this. Now I am telling you this is correct circuit diagram. Just switch it on. Okay, once if everything is ready, then you plug in this. Okay student, till now we have connected the circuit. Now circuit is correct. Now just switch on the battery. Okay, if once everything is right, plug in this. So now your circuit is completed. So I told you already the procedure. Set one rheostat position, set the current, note down the voltage and draw the graph. This is the simple way to tackle this experiment. Okay, so how to take the readings from milliammeter and voltmeter? See students, you need to get the value of least count. See, very simple. Least count means, look at this divisions, 0 to 100 means 0 after 10 lines the value is 100 milliampere. It means each individual line value is a 10 milliampere. Okay, so it means in ammeter its least count will be 0 to 100 means 100 milliampere divided by 10. So each individual line value is how much? 10 milliampere. Means suppose if the needle is in second position, 0, 1, 2, 3, second position, 2 into 10 it will give 20 milliampere. If it is in 6th line, 6 into 10, 60 milliampere. Similarly in the voltmeter, what is the least count? Look at this 10 division, 0 to 0.5. So 0.5 volts divided by 10, it is 0.05 volts. It means individual line value in the voltmeter is 0.05. If the needle is in second position, 2 into 0.05 will give the voltage. If the needle is in fifth line, 5 into 0.05 will be 0.25 volts. So 0.25 volt you need to write here. Okay, so this is how you need to take the readings. Now let us start the experiment. Okay, so I am going to keep one rheostat position. Here I have got some values already, but let us start with some standard values. I am going to keep, see, by varying this you need to see this current. See here 0, 1, 2, 3, the bigger line is 5, in between that 6, 7, I am going to keep at 80, means 8th line. So now it is at 8th line, 8 into 10 it is 80 milliampere. So here you need to write 80 milliampere. And here only you make sure that it is in milliampere. Here current in milliampere. In the header part only you write it. So 80, how much voltage you are getting? See, it is in 6th line. Okay. So it is in the 6th line, 5, 6. Just say 5, 6. So 6 into 0.05. So 6 into 0.05 will be 0.3. Okay. So 0.3 volt. Now similarly maintain some 20 milliampere gap. Now set at 100 milliampere. So for 100 milliampere, how much current you are going to get? So for 100, it is in 8th line. So 8 into 0.05 will be 0.4 volt. And similarly, I am going to take 20 more difference. So for 120 milliampere, so for 120 milliampere, it is in the 5th line. So it will be like 5 into, not 5, it is exactly 0.5 volts. It is already at 0.5th line. So at 120 milliampere, what is the voltage? 0.5. Okay, students, in this way you need to take all the values. Okay, so we have to repeat this. Now by varying this, okay, by repeating the same thing, like after setting at 140, 160 and 180, I got 0.8. Okay, keep it original now. So by repeating it, by varying the rheostat position and keeping it 140, 160 and 180, we have got voltage 0.6, 0.7 and 0.8. Once we get these all values, now draw the graph. Okay, I have drawn already the graph for this. So current values, it starts from 80 milliampere, 100 like this. So current value are in the y-axis, voltage's value are in x-axis. So I have taken from 20, 40, 60. Here y-axis you need to write current I in milliampere, 20, 40, 60, 80 up to 200 milliampere I have written, and voltage I have taken 1.1 volt, 0.2, 3 like this. It means on y-axis you need to write scale compulsorily. In exam you have a marks for this. So on y-axis 1 unit is equal to 20 milliampere, and on x-axis 1 unit is equal to 0.1 volts. Okay, on y-axis 1 unit is 20 milliampere, on x-axis 1 unit is 0.1 volts. So this is your scale. Now draw the graph. So for 0.3 volt I have got 80 milliampere, 0.4 I have got 100 milliampere, 0.5 120, 0.6 140, 0.7 160, and 0.8 I have got 180. In this way we have got a straight line, means linear graph. Okay, if I start reading from directly 0.3 here and 80 here, I could have got directly from origin, but since you are maintaining some gap, so it is also after some gap the straight line starts. Okay, so you have got a straight line. It means what? In this conducting wire, how your current is changing, in the same way the potential difference is also changing. Okay, how the current is changing, in the same way potential differences goes on changing. It means it is Ohm's law. Current is directly proportional to voltage. By varying the current, you are going to have the change in the voltages. If it is semiconductor, you won't get these kind of relations. Okay, so since it is a conducting wire, okay, by varying the current, you are going to see the change in the voltages by maintaining all the temperature and other physical condition constant. Okay, so here once we draw the graph, now take the slope. So slope, we know that slope we have know the formula y2 minus y1 divided by x2 minus x1. So here I have taken A and B are the 2 points in x-axis, in y-axis. So it will be AB means what? This A minus B divided by BC, means BC are the points on the x-axis, AB are the points on y-axis. So which are the 2 points on y-axis? 160 minus 100. So 160 minus 100 divided by, what are the BC points? 0.7 minus 0.4. 0.7 minus 0.4. So this is going to be 60 divided by, so make sure that the current is in milliampere. So you need to write here milliampere and it is in volts. So into 10 to the power minus 3. So this is, look at this. So 6 into 10 to the power minus 3 here plus 1. And this minus 1, if it goes upper means it will become 1 more plus 1. So divided by 3. So this is 2 into 10 to the power. So this is 3. Correct? So this will be how much now? 3 minus 2, it is minus 1. So what is the slope? 0.2. So this is what your M. So M, how much we are getting? 0.2. But what is the formula? Resistance of the wire. So resistance of the wire is 1 by slope, that is 1 by 0.2. So this is nothing but what? 1 by, this is 2 by 10. So this is 5. 10 will go up, 10 by 2 is 5. Hence, what is the value of resistance of the wire from slope method? 5 ohms. And what is the resistance per unit length? So resistance R is 5. The given length we have given you the 1 meter. This is 1 meter wire which is winded on a stick. So this is 5 ohm per meter. Hence we got the result. Resistance per unit length is 5 ohm per meter. So this is how we saw that the Ohm's law we have proved by taking a conducting wire, changing the current, we have observed change in the voltages. By maintaining all the other physical conditions and temperature constant, we have proved that current is directly proportional to voltage. How current is changing? Voltage is also changing in its value, and current is also changing in its value. So hence, see, for example, V and I we have V equal to IR. If I divide V by I, you are going to get resistance. This is what we have done here. 1 by M means what? Slope. This slope is nothing but we have taken slope of I versus V. So that's what we have taken 1 by M. If it is V versus I, we could have taken directly R equal to M. Okay, so this is what the first experiment. So you need to find out the resistance of this unknown wire. We don't know what is the resistance of this wire. So with the help of this setup, we have find out the resistance of the unknown wire. Okay students, this is what the first experiment. Write it properly in the journal. On the blank sheet, start with circuit diagram, nature of graph, observation table, observation, and do the calculations and draw the graph properly and do the calculations also. Okay, at the last write the result should be written in the ruled paper. Result should be written in the right side paper, and on the right side beginning write the experiment number, date. Right now don't put the date, just leave it as it is. Write the experiment number, title, and follow with this. Okay, thank you.